Okay, welcome back to part 2 for adjoint, inverse, and Cramer's rule. We've already gone through a couple of things in here. We have talked about the adjoint and the inverse, and this was the example that we did on the slide, and then here is the example that we did on the paper with our equation, our three equations, three unknowns up here at the top, and then we calculated the cofactor expansion, took the transpose of that for the adjoint over here, and then 1 over the determinant times the adjoint gives you the inverse. And that's where we left at the end of the video for part 1. So that's how you use the adjoint, the determinant together to calculate the inverse. What I want to talk about in this second video is Cramer's equation. Cramer's equation is pretty powerful in that you can calculate each of the variables. In this case, you can calculate the value of x, the value of y, and the value of z separately, just simply by working with the determinant and then separately calculating the determinant in each case when you replace the first column of matrix A with the constants, in this case 1, 0, 2, and then we'll solve for y by replacing the second column with 1, 0, 2, and then you can solve for z by replacing the third column. Let's make sure that's all really clear. So we'll use this example on the PowerPoint, and then we'll go back and we'll continue with this example on the paper. So you have three equations and three unknowns. Here are your three equations. X, Y, and Z are your three unknowns, and we can take this and just looking at the coefficients, we have the matrix right here, negative 1, 2, negative 3, and 2, 0, 1, and 3, negative 4, 4, matches up with these coefficients. We can calculate the determinant of this, and that's 10. So the determinant of the coefficient matrix is 10, and we're going to use that in the denominator of the equation to calculate the value of x, the value of y, and the value of z. All right, so if you'll follow along carefully with this second slide, here is just the matrix of the coefficients, and as was on the previous slide, we found that to be 10. So what we're going to do is to calculate the value of x, y, and z. Here on the screen it shows you this is how you calculate the value of x. For the value of x, what we're going to do is we're going to replace this first column of negative 1, 2, 3. We're going to replace it with 1, 0, 2. Why 1, 0, 2? 1, 0, 2 are the values that each one of these three equations are equal to. So 1, 0, 2 is put in place of column 1 in matrix A because we're going to solve for x. If we were solving for y, we would switch out the second column for 1, 0, 2. And solving for z, we would switch out the third column. So whichever variable you're solving for, that's the column that you switch out and replace it with these constants 1, 0, 2 from the three equations, three unknowns. And when you do that, when you replace 1, 0, 2, then you can calculate the determinant of this numerator. You can certainly punch this in your calculator, or you'll notice we got a couple of zeros here, so plus, minus, so that's going to be negative times the determinant of 1 times negative 1, 2, 2, and negative 4, or in other words 1 times negative 4 minus 4, or which is negative 8. So negative 1 times negative 8 is 8 tenths, so positive 8 tenths and 4 fifths. There you have it. 4 fifths is the solution for x. X has a value of 4/5 for these three equations and these three unknowns. Okay? And like I said, if you wanted to figure out the values of the other two, the values of y and z, you would go through the same thing, except for to calculate y, instead of 204, you would replace 204 with 102 and go through the same process. And then to calculate the value of z, you would replace -314 with 102 and calculate the value of z. This is kind of a cool deal that's using Cramer's theorem, because you can individually calculate the values of x, y, and z. They don't depend on the other, but that's how that works. Let me slide over here to our problem that we're working on. In this case, this equation here, we've already calculated the determinant. We know that the determinant is -3, and so we can calculate the value of x, the value of y, and the value of z using Cramer's rule. Let me just jump ahead. This, as you can figure out, Cramer's rule does not involve using the adjoint. But if we wanted to figure out the value of x, in our case here, we would need to calculate the determinant of, we would switch out -3 to 0. We would switch that out and replace -3 to 0 with 12, -9, 15. And we got -541 and -7, 3, -1. Calculate the determinant of that, divided by, what did we say the determinant was for this system here? We said it was -3. So you're going to divide by -3, and that's going to give you the value of x. Calculated the determinant of this. Feel free to punch that, this matrix here, punch that into your calculator, and you'll be good to go. If we wanted to calculate the value of y, then we're going to replace this second column, -541, we're going to replace that with 12, -9, 15. So we've got, in the numerator, you're going to take the determinant of 12, -9, 15, and -7, 3, 1. Calculate the determinant of that, divided by -3, and that's going to give you the equation for y. And then for z, you're going to replace the third column. So you got -3, 2, 0, -5, 4, 1, and then 12 and -9, 15. And divide that by -3, and that'll give you the value of z. Okay? Now I'm trusting you folks to plug this in, calculate the determinant. When you switch out column 1, so you can figure out x, switch out column 2 so you can figure out y, switch out column 3 so you can figure out z. And what you're going to get here, you are going to get, if this is all correct, if you do that correctly, you're going to get -73 for x, you're going to get 26 for y, and you're going to get 11 for z. Okay? Now, let me check something. I forget. I really do. Oh, here you go. In this case right here, this is what I need to tell you. X, we did all this. We got 4/5. If you plug in the 102, if you plug that in for the second column up here and solve for y, you're going to get negative 3/2. And then if you plug in 102 for the third column to solve for z, you're going to get negative 8/5. So x is 4/5 in this case, y is negative 3/2, and z, in the example here on the PowerPoint, z is negative 8/5. Okay? Now in your homework, this is what you're going to be doing. You're going to be using the adjoint to calculate inverses, and you're going to be using Cramer's rule, the Cramer's theorem, for calculating these values x, y, and z. Feel free to use your calculator, crank through the determinant using your calculator, and you can always check your work on the inverse. You can always check your work using your calculator as well, but it is important that you know how to use the adjoint method for calculating inverses, and as well as Cramer's rule for calculating x, y, and z. Alright folks, that is what I have for you for section 3.3, and if you have any questions, please let me know. Hopefully you've seen on Pearson that you've got some time to get the homework in, a few days, but goodness, spring break is upon us, and I don't think you want to have this homework hanging over your head come Sunday night. So if you could bust it out prior to the weekend being over, you'll have a far more enjoyable spring break. You guys be careful, enjoy your break. I'll tell you what I know your mom and dad might want me to tell you. Your parents would much rather you arrive home a few minutes late than for you to end up in a ditch and them have to come get you. So traveling mercies for you. Be careful on the road, and I look forward to seeing you in 2 weeks, a little over 2 weeks, as we get back into linear algebra together. Have a great break. Peace.